Here. Okay, now we're recording. Okay, let's talk about soil particles and physical properties of soils. How's that showing up for everybody? Good. All right, so physical properties, lecture 5. Now, I don't know why I loop or I kind of grouped soil color into here, because it's usually not related to a physical property. It usually has something to do more with chemical properties, and especially iron. But let's talk about color real quick, and I think we've alluded to a lot of this. One of the things that we use in soil science, and I have a copy right here, is this. It's called a Munsell soil color chart. Okay, and inside of this, there's a bunch of different pages, and I wish you guys were here. This is one of the dumb things about not being able to meet in person. But inside of this book, you can kind of see these color chips. It looks an awful lot like when you go to Home Depot or Lowe's or whatever and try to buy paint, and there's all these different color chips. Well, we do the same thing with soils. And what we'll do is we'll take some of the soil, and you can kind of stick it on your finger and hold it. There's little windows on here if you can't see that. You can kind of hold it behind the page and then make a comparison based on the color. And the way this thing is set up is, if you look at the slides here, we've got a wet number that because obviously when soil is wet, it's a different color than if it's dry. So a lot of the times, like if you go to those official soil series description pages, you'll see it'll give a color, and it'll give a wet color and a dry color. And the way this comes out is we have a hue, which is the red or the yellow. So let me see if I can show you guys these tabs. How's the picture look? I know there's these tabs on the side, and those give us our yellow or red color. And so the way these are organized is it starts with 10R, which is 10 red. And you'll notice that these colors right here are definitely on the red side of the spectrum. And then as we get to the yellows, here's the yellow, the furthest yellow page. And so that's what that hue number is it's a kind of a combination of red or yellow. Most of the soils that we see are in this, like, it says 7.5 YR. They're kind of in that realm, or you might get like a 10 YR. But these are the most common soil colors that we see. Okay, and within this plate, as we go from top to bottom, that is the hue. Excuse me, that's the value. So from top to bottom, we're increasing in darkness. So you can see that it starts out light and goes darker towards the bottom. So that's our value. And as we go from left to right, that is our chroma, or the brightness. So if you were to look, let's take this top row right here. As you go from there to there, you can see how the brightness is increasing. So that's basically how one of these Munsell color charts work. I've worked in soil science for I think it's been 18, 19, almost 20 years, and I've used this like 5 times. But it's easy, it's fun. I mean, you do it a few times, you kind of get the hang of it. Okay, what's causing color? Iron and aluminum oxides. We've established this, right? Also, organic matter is a big player, so we get that dark black brownish color when we get a lot of organic matter. And then another thing, obviously, is carbonates. So when something gets this white color to it, especially in arid soils, we'll get that white color, and that's from carbonates. Okay, we're going to kind of take a veer of direction right here and talk about soil texture, okay? Now, when we talk about soil texture, we're talking about sand, silt, and clay, and nothing else, okay? Now, have you guys heard the word loam or sandy loam, things like that? Now, what a lot of people think, and it's probably your grandma, she's going to say to you, Rod, I want to make my soil into a loam, and so I'm going to add a bunch of organic matter. Okay. Now, being the astute soil science student that you are, you're going to say, well, organic matter is really good, Grandma, but it does not turn your soil into a loam. And I'll show you in just a minute why that is. Just remember, organic matter is not part of soil texture. Why do we care? Well, for one thing, soil texture tells us a lot about what water holding capacity is, and that is then related to nutrient holding capacity. It tells us a lot about the soil. Now, I want you guys to ignore all of this, except for this very top line. This is the USDA size classifications, and it's for clay and silt, clay, silt, sand, and I want you to ignore this part over here. So all I need you to remember for this class is that sand is anything from 0.05 to 2 millimeters. A silt is anything from 0.002 to 0.05. And then a clay is anything that's less than 0.002. And that's a diameter number, and that is in millimeters, okay? Millimeters. It's pretty small, right? Millimeter. Anyone have a ruler handy? I just changed my desk up, so I forgot where my ruler is at, but a millimeter is pretty dang small. And if we were to kind of look at these things on a size, if we were to visualize the size, so remember this big guy right here, sand particle, and sands are anywhere from 0.05 to 2 millimeters. A silt particle is from 0.05 to 0.002, and then a clay particle is tiny. Now, you guys, I'm getting old here, and my vision is turning to pot, especially like my near vision, my nearsightedness. My kids will hold something up to my face to read, and I automatically go like that. You guys aren't there yet, but you'll get there, believe me. I used to think my dad was crazy because I'd put something up to his face and he was always like this. But none of us can see a clay particle. They're too small. And even the small silt, I don't think that we could see individual grains of the smaller silt sizes either. We can see sand, and we can even see the fine sands, but somewhere in that silt range is where we go from being able to see something with the naked eye to microscopic, okay? So keep that in mind, that the size classification, it's pretty wide, right? Okay. This is a dumb slide. It's just showing you like different diameters. So if we're looking at a diameter of 0.1, can you see the little dots in there? Okay. And at a 0.1, we can see those dots, but that's still in the sand fraction. So yeah, pretty small still. This is as big as the biggest sand particles are. This is all relative, right? I don't think these are actual sizes. Okay, how do we determine soil texture? On Tuesday, we are going to physically meet in lab, and we're going to do texture analysis, and we're going to do it two ways. We're going to do it by feel, okay? This is the thing that your grandpa does, you know, go out and grab some dirt and squish it around in your hand. We can get pretty accurate with doing it by feel. Another method is by hydrometer. I'll tell you about that in just a minute. And then there's another one where we do it with pipettes. I don't like this method. It's cumbersome. It takes a long time. And so for this class, you can just ignore it, but maybe remember that there is a method for it. Which brings us to Stokes' law, okay? Stokes' law, in kind of a nutshell, is how fast things settle in liquids, okay? And we know that things that are heavy and have low surface area are going to settle very quickly, right? So in layman's terms, it's the speed at which something settles is proportional to gravity and the difference between the density of the particle and the density of the fluid, yada, yada, yada. It's basically how fast something is going to settle in a liquid. And we can use Stokes' law to help us determine texture. And let me show you how that works. So if we simplify this thing, we can determine all these different variables. This one right here, let's pay particular attention to that. So this is telling us right here time, okay? And the time that our particle is going to settle depends on how far it needs to fall. That's what the h is. And its diameter, which is the d squared. And then k, that's just a constant right here. That's the 9 times 10 to the 5th second meters, okay? This is basically the hydraulic, you know, like when it's viscosity. That's a better way to put it. It's viscosity. So this is the viscosity for water. If we were to do this like in oil, imagine if you dumped a bucket of sand in oil. It's going to settle much slower than if you did it in a bucket of water, right? That's what this is telling us right here. All right, so the way this works is in the lab, we'll take the sample, and you guys are going to get to do this on Tuesday, in person, live, face mask and all. What we're going to do is we're going to take a soil sample, and to it, we're going to add a chemical dispersant. And we'll talk about that in the future, what that means, but that's important. What that's going to do is it's going to separate sand particles, silt particles, and clay particles into their individual units. And we put it into one of these cylinders. This is called a Boyuka cylinder. And what we'll do is we'll shake this up, we'll give it a good shake, and we'll put in a hydrometer. And I think, you see this little stem sticking up right here? That is a hydrometer. A hydrometer basically measures floaties. Do we have any winos in the group here? If you ever go to like a wine tasting place, you might see some hydrometers running around. They'll put those in there to measure floaties. We're going to do the same thing with soil. And so what's happening is if we shake this thing up, Madison, what's going to be the first thing to settle out, sand, silt, or clay?
The clay.
The first thing to drop to the bottom.
Oh, the sand.
There we go. Yep. So the sand. And so we know, based on the height of this column right here, that after 40 seconds, every bit of sand is going to be settled out. And if you look down here closely at the bottom, you can kind of see there's a layer of sand down there. Okay. And that means that the hydrometer is measuring everything that's floating. And so, Wade, what would be left floating if the sand settled out?
Silt and clay.
Yep. So after 40 seconds, this thing is telling us how much silt and clay is still in suspension. Okay. Great. The beauty of that is that if we know silt plus clay, we also know sand, because these things have to add up to 100%. These are given in percentages. So if we know how much silt and clay is floating, we automatically know how much sand is settled out. Okay. And then what we'll do is we'll wait for 2 hours and we'll take another reading on the hydrometer. And after 2 hours, all of the sand and the silt have settled out. And so then, Rod, what's the hydrometer going to tell us is floating still? If the sand and the silt have settled out, what's floating?
Clay.
Perfect. Okay. And so if we know the sand and we know the clay, we can figure out the silt, because all these things have to add up to 100%. Great. Close up. Now, what you're looking at here, this is the USDA texture triangle, okay? And again, everything is given as a percent. So percent clay, percent sand, and percent silt. And all we need to know is two of the parameters, and we can figure out what our texture is. So the textures are giving in these, this is a sand texture, sandy loam, clay loam, silty clay. These are designations of texture. So Joe, I'm going to ask you again, where does organic matter fall in this table?
Does it not?
It does not. Perfect. Okay. So if anyone ever tries to tell you that they're going to add organic matter to change their texture to a loam, you can quietly laugh to yourself and think to yourself, well, you're an idiot, because organic matter is not part of this. Okay, let me show you how to use this table. You see these arrows right here? So here's an arrow for sand, and here's an arrow for clay. This one goes horizontally. This one goes diagonally. What I'll do is I'll give you some numbers, and you're going to tell me what the texture is. So let's see. Who haven't I picked on yet? Lily. Let's say that we have a texture, and I tell you that the sand percentage is 50 and the clay percentage is 20. What is our texture? So the way you do this is you find 50. So I told you we had 50 of sand, and you follow that up diagonally.
You would have a loam.
Yep. And here's our clay. You follow it across horizontally where the two intersect. So 50 and 20 intersect right here. We're solidly in the loam. Clear as mud? Garrett, you want to do one? Okay, let's say that you have 30% clay and 70% silt.
That would be a silty clay loam.
Okay, so let's follow, I said 30 of clay, so let's follow that across. And what did I say of silt? 60 or 70? Something like
70.
that. 70, yeah. So that'll put us right here in the silty clay loam. Does that make sense to everybody? Okay,
Yep.
I think I've got some examples here. So let's look at this first one. What is the texture of a soil that has 20 of sand, 15 of silt, and 65 of clay? We only need to remember two of these, right? They add up to 100%. So let's remember the 20 of sand and the 15 of silt. Whoops, I'm going to go back. So 20 of sand and silt is 15. Shoot, we got to go way the heck up here. So that's a clay. Pretty solidly clay. You notice how clay dominates the texture triangle? A little bit of clay goes a long way. All right, you guys do the next one and tell me what you get. So 65 of sand, 20 of silt, and 15 of clay. Chris, what'd you get? You're on mute, man.
It was 65 of sand, right?
Let's see, 65 of sand and 20 of silt.
Okay.
So,
Clay?
no, I don't think so. So let's 65 of sand. Where'd my pointer go? Dang it. There we go. 65 of sand, and we'll follow that up diagonally. And I think it was 15 of silt, right? So we're like on a sandy clay loam right there. Kind of border between a sandy loam and a sandy clay loam. I think it would probably fall in this sandy clay loam category for sure. Is that what everyone else got? Okay, let's do this last one. 20 of clay and 40 of sand. Wait a minute, I only gave you 2, right? We're not going to fret because that's all we need. So 20 of sand, no, 40 of sand and 20 of clay. Madison, what do you got?
What did you say? 20 of clay and 40 of sand?
Can't remember. 20 clay, 40 sand.
Okay. And then I got, would it be a loam? Or I have to go all the way up?
So let's follow 40 up to 20. That puts you right on the line, doesn't it? Right there?
Yeah.
Is that what you guys are getting? No, what are you getting, Wade?
I'm getting a
loam
loam.
because it's 20% sand,
Yeah.
40 sand.
20% clay.
Oh,
That's
clay.
what my confusion
I was doing
'cause I got-
silt. I'm dumb. Okay. Yeah. 40 and 20. That's a loam. Okay, we'll practice with that. Obviously, I need some too. It's hard because we got to go back and forth, right? Which one's which? Okay. Anyway, but you guys see how it works, right? Just be sure. I know that there's going to be questions on the test about this. Just be sure that you're following this line the right direction, right? Because you don't want to go, dang it. You want to say, okay, I've got 60 of sand and then follow it up this way because that's going to mess you up. Okay, it's got to follow the same direction. Okay. All right, you guys. You're probably going to hate me for this, but we are not going to meet for class tomorrow. That sound good? Now, having said that, I've posted an assignment on Canvas for you to do. Are you guys familiar with Microsoft Excel? Give me a thumbs up or a thumbs down. I don't see everyone's thumb. Okay, Chris, where are you at? Good. Okay. Well, let me, if I might, I'm gonna show you like some really basic Excel stuff. And I am an Excel nut, and I insist that you learn how to use it. Can you still see my screen? I insist that you learn how to use it because for me, of all the different computer programs that I've ever used, like I use Excel way, way, way more than anything. And, you know, if I hire people occasionally, and if I had a choice to hire 2 people that were equally qualified, except that one knew how to use Excel and one did not, I'd take the Excel person every time. Okay. So what I want you to do for this assignment, and it should have posted maybe a few minutes ago, but what I want you to do is create a calculator that can answer these 2, or actually there's 3 questions right here. So what's the hypothetical is you go out and you dump 2 millimeter sand into a 50-foot lake. And the question is, how long does it take for the sand to reach the bottom? Okay. And all the information that you need to know is right here. And it is right here with these 2, this equation. This is the equation that you're going to set up, and this is your K. Okay. So you have I've given you a diameter, I've given you a height, and I want you to calculate time. All right. Now, if you're not familiar with Excel, I'm going to just show you some really basic math concepts. So if you ever want your computer to do math for you, it's super easy. So let's put in 2 values right here. Let's put a 2 and a 5 right here. Okay. if you want this thing to calculate the sum of those things for you, there's a couple ways of doing it. The easy way is there's a little thing up here that says auto sum. You guys see that? If you click on that, it'll sniff out the data for you. Then you just hit enter and it gives you the right answer. The other thing you can do is you can just hit equals sum and highlight these two cells like that. That's one way of doing it. Or you could just say equals that plus that, and it works. The beauty of this is that now you can go in here and change these numbers. So let's say you put a 0 in here. You'll notice that it updates the 5 automatically. Okay, it doesn't stop with addition. We can do, let's say, equals that minus that, and it works. That's addition, subtraction. If you want to do like division, equals that divided by that, it's going to give us a 1. Okay. Multiplication. This stuff's all available online. You know, if you get caught on something, you can just Google it or YouTube it, and you can find an answer 99% of the time on how to use Excel. Okay. Any questions?
I have one.
Yeah.
Do you accept Google Sheets? It's pretty much the same thing, just free.
Yep.
Okay.
Yep, that'll work. Yeah, so I this is going to challenge you guys, by the way, because you'll notice here that this constant right here is given in seconds and meters. And so that being the case, I've given you height in feet. You've got to change that height into meters. And I've given you diameter in millimeters. And so you've got to convert that too. So that's the challenge, is make sure that your units match, and then you'll be able to set this thing up once, hopefully, and you'll be able to type in, okay, my the diameter is 2 millimeters and the height is 50 feet. And down here somewhere, after you do all these calculations, it's going to tell you your answer in seconds. So I think this ends up being like 2 seconds or something, if I'm not mistaken. Don't quote me on that. But you should be able to come up here and then change. All right, well, I've got a clay particle now. You put that in there and it does the math for you automatically. That's how I want you to set it up. Sound good? You've got till midnight tomorrow to get this done. And if you have questions along the way, I don't care if you guys work together. You can bug me. If you want me to take a look at your sheet, I'll be happy to look at it. But yeah, that's all I've got for today. We good? Great. All right. So yeah, no class tomorrow in person. Work on the assignment, have it submitted by midnight tomorrow, and we will talk again on Monday on Zoom. Wait, is Monday a holiday? Okay.
Yeah, it's Martin Luther King Day.
Okay, so we will be meeting in lab in person physically on Tuesday then.
Are we in the same classroom that your wife was in for plant science?
Yeah, so you walk into the new education, workforce education building, take a right, and it's the, I don't know, it says agriculture right above it.
Yeah.
Hopefully we get in. I don't even have my keys yet. I went to go get them yesterday and they're like, who are you again? And I was like, I've been doing this for 7 years, guys. And every year it's the same thing. They're like, oh, come get them on Monday, but Monday's a holiday. So maybe I'll get them on Tuesday before you guys show up. Okay, sounds good. We'll see you guys later. Have a nice weekend.
You too.